Today we're going to talk about writing equivalent expressions. Equivalent means they equal the same thing, but they're written differently. That's really the kind of rough definition of equivalent. Written differently, but meaning the same thing. So we're going to find some equivalent expressions. What this is really going to help you with is when we get to algebra. But right now it's going to seem like it doesn't go with anything else because it's kind of different than what we've been talking about. But we're going to use the ladder that we made yesterday, or the cake that we made yesterday. So we're going to use the cake that we made yesterday to help us find these equivalent expressions. Because what we're really doing is we're taking out the greatest common factor of a set of numbers, and then we're writing the rest of it in a different way. So you'll see what I'm talking about in just a second. So this is your how-to that you already glued into your notebook. So let's just go straight into an example. If I give you this problem, 12 plus 16, write it on your paper.
In the bracket?
Just on your paper. So if I give you this problem, 12 plus 16, okay, here's what most of you will do. You'll write 12 plus 16. 6 plus 2 is 8. 1 plus 1 is 2. And you'll get the answer 28. And you'll be right. That's right. That's a correct answer. But what they want you to be able to do is to look at 12 and 16 and take out the greatest common factor and rewrite it a different way. So that's what we're going to do right now. We're going to look at 12 and 16 and we're going to take out the greatest common factor. So we're going to write 12 and 16 and we're going to make the cake. So we're going to make the cake for 12 and 16. So what's the smallest number that divides into both of them? 2. 2 goes into 12 6 times. 2 goes into 16 8 times. Wait till I ask, okay? How about 6 and 8? Do they have a common factor? Yes. What is it? 2. So we're going to do another 2. So 2 goes into 6 3 times. 2 goes into 8 4 times. Common factor between 3 and 4 besides 1?
No.
No more common factors except for 1. Doesn't count, so we don't have to use it. And then we're going to rewrite it using this format right here. This is what you're looking for. So, and I'm going to show you why this works in just a second. So the outside number, the number we're multiplying by, is the greatest common factor. And the greatest common factor of these two numbers is 4, because 2 times 2 is 4. Okay, the numbers inside of parentheses then are these two numbers right here. 3 plus 4. So we can rewrite the expression 12 plus 16 as 4 times 3 plus 4. And I know some of you are thinking, why? That doesn't seem logical. It will when we put letters in there. And that's the whole purpose, is when we get to algebra, there will be some letters in there. But I do want to prove to you that this works, okay? So we said that 12 plus 16 gave us 28, right?
Yes.
So let's do this problem right here. First we'll do what's in parentheses, which is 3 plus 4, which is 12. Nope, 3 plus 4, I multiplied. Sorry about that. 3 plus 4 is 7. Now, I'm going to put my 4 next to parentheses. Who knows what that means? Ooh, good. Some of you do. Excellent. Devin, what does it mean? It means multiply. Whenever you see a number next to parentheses and there is nothing between them, no symbol between them, it means multiply. So this 4 and parentheses 7 is the same thing as 4 x sign 7 or 4 dot 7. Means the same thing. So it means 4 times 7. What is 4 times 7? 28. So look, we got the same answer answering it both of these two ways. So we got 28 when we just added it, and we got 28 when we performed this operation right here. Okay? And I know, remember, we're learning something about algebra. This is going to take us there, and that's the reason why we're learning this skill. Okay. Write this one on your paper. We have 60 minus 45. 60 minus 45. So I'm going to go over here real quick and I'm going to go 60 minus 45. Borrow 5, 10, 5. 60 minus 45 is 15. Everybody okay so far?
Yes.
But now we're going to rewrite it using that equivalent expression. So we're going to make the cake 60. And when I do this, I usually put that symbol right in between it so I don't forget whether it was add or subtract. Because remember the last one was adding? This one's subtracting. So I like to put that symbol in between when I make the cake so I just don't forget what it is. So 60 minus 45. Common factors between 60 and 45. What's the smallest one, Anna? 5. 5 goes into 60 12 times. 5 goes into 45
3 times.
9 times. Oh, there was a smaller one. I'm sorry. My bad. But there's another one. What is it? 3. 3 goes into 12
4 times.
4 times. Good. 3 goes into 9 3 times. Okay. So any common factors between 4 and 3 besides 1? Nope.
No.
So we're ready to rewrite it with our parentheses. What is this? 15, because 5 times 3 is 15. And then our numbers are 4 minus 3. And we can check it to make sure we got the right answer, because 4 minus 3 is 1. So we have 15 times 1. 15 times 1 is just 15. We got the same answer both ways. All right, you see if you can do this one. See if you can do this one. Follow the format. See how far you can get. I'm going to help you in just a minute. All right, how many people have, you may not have the exact same numbers, but over here you should have 20. How many people have 20 as their greatest common factor? Good. And then we have 1 plus 2. So when we rewrite it, it's going to be 20, 1 plus 2. Let me prove to you that that works, okay? So we're going to first add 1 plus 2 and we'll get 3. So 20 times 3, what is 20 times 3? 60. And when I added those two up, I got 60.